Welcome to NetX Tamil. Today we are going to discuss about dynamic routing protocol, in that RIP, router information protocol. See, this protocol is a basic routing protocol. Okay, in modern days this routing protocol is not much used, but this is a basic we need to understand. Then only we can understand more about the advanced routing protocol. Okay, in upcoming session we will see this routing protocol in detail with the lab. Now let's understand how this routing protocol works, what is the advantages, what is the disadvantages, all those things we will briefly discuss in this video. See, the routing information protocol, we will call it as a RIP routing protocol, which is one of the dynamic routing protocol. In previous video we have discussed about static routing protocol. If you have any doubt about the routing, static routing, please go through my previous video. This routing protocol is open standard routing protocol. Open standard means we can use it in any of the routers. It's not particular OEM proprietary. See, some of the things are the OEM proprietary. We cannot use into the other OEM devices. For example, if you taking the LAN redundancy protocol HSRP, which was a Cisco proprietary, we cannot use it in any other OEM devices. The HSRP and all we will be discussing briefly in upcoming videos. See, if you take EIGRP previously it was a Cisco proprietary. We cannot use it in EIGRP is one of the dynamic routing protocol which we cannot use it in any other routing, any other OEM product previously. Now Cisco has released that their proprietary, and then now it is became a open standard. Now we can use it. But before 2013, okay, till that time it was a Cisco proprietary. See, this routing protocol RIP works based on the distance vector routing protocol, works based on distance and direction. It uses the Bellman and Ford algorithm. This best path can be selected using the metric called hop count. Hop count means how many stops are there in between. For example, if you're taking India to France, we can go multiple ways. From India, if I'm starting from Chennai to Delhi, Delhi to Dubai, Dubai to France, I can go in that way. Or I can go directly Chennai to Dubai, Dubai to France. So the first path, what I said, there are two in between hops. If second path, if I say there is only one hop in between, which is Dubai. In first path, I said Delhi and Dubai, two hops. Then it will be taking the path of second option. Why? Because it is having only one hop. It will not look at a distance, time, anything. Okay, only it will look the hop count. How many hops are there in between the path? Based on that, it will be choosing the best path. It supports only up to maximum 15 hop count. If it is more than that, it will not support. It support equal cost load balancing. If there is a multiple route on the same destination and their metric value is same, metric value in the sense hop count, if it is the same, then it will be doing the equal load balancing. Equally, it will be load balance the traffic. And then it supports by default maximum 4 path. Admin can extend up to 6 path. It does not support unequal cost load balancing. If it is the different metrics are there, then we cannot do the unequal cost load balancing. It will not support it. Only equal cost load balancing, it will be supported in the RIP. And for every 30 seconds, sends a complete routing information to the neighbor. So every 30 seconds, will be connected neighbors will be sending the data. Okay, this is one of the disadvantages also for this router. Okay, it will be more consuming the traffic from the neighbor and CPU utilization. Every 30 seconds, it has to send the update to the neighbors. Then is AD value. AD value is administrative distance value, which is 120. And then the 120, if you static routing, if you see the AD value is 1. If it is a connected route, The network which is configured in a router or switch itself, that will be AD value will be 0. Okay, for static route the AD value is 1. For RIP routing protocol AD value is 20. See, if it is a same destination we have receiving the over the RIP and static route, then static route will be preferred. Why? Because the static route AD value is 1, the RIP AD value is 120, so it will be choosing the static routing based on the least AD value. That route will be always preferred. Let's see in this diagram, from here to here, if I go via this, there are 3 hop. If I go via this, 2 hop. If I go via this, 4 hop. Then this path will be chosen, best path. Now in this RIP there are two versions, RIP version 1 and version 2. The RIP version 1 supports broadcast 255.255.255.255. The RIP version 2 uses the multicast 224.0.0.9. So the RIP version only supports the fixed length subnet mask, which means, okay, the classful address. That means classful network. If you take a slash class A, only slash 8 you can use it. If you take a class B slash 16 and then class C slash 24. But in RIP version 2 you can do the subnetting. Okay, those subnet, the variable length subnet mask can be used in the version 2. If you are using a subnetted network, those can be used in the advertised in the RIP version 2. That is a classless network. This a RIP version 1 can receive and send with any version 1 and 2, the combination will work. But RIP version 2 combination will not work. It should be sent by and received by RIP version 2. See, there are 4 important things. Timing is there in RIP routing protocol. This update every 30 seconds, update the routing information to the neighbor. Every 30 seconds it will be update the routing information to the neighbors. And then invalid, 180 seconds the router will wait an update from a neighbor. If does not receive an update in 180 seconds, then it marks as particular route as unreachable, possibly decent route. Then hold on time, that is also 180 seconds. Every router keep hold their update every 180 seconds. And then flush time, the router will flush the marked unreachable route from the routing table once its timer expires. See, the invalid, it will wait for 180 seconds and it will mark as a 180. After that it will wait for a 240 seconds. After once the time expires, okay, it will flush the routes. If it is not receiving any update till on 240 seconds, it will flush the routes. Let's see the advantages and disadvantages of this RIP. See, this advantages for this RIP is easy to configure and then support different topology as well. Disadvantages, this routing protocol consumes high CPU utilization since it is 30 seconds update, it has to get it every 30 seconds. And then limitation number of hop router, only 16 router it will support. Okay, if it is a hop count is more than 15, it will not support. And slow convergence, see, if a route is going down, it has to get immediately updated, right? It has to wait for a 240 seconds. 240 seconds means nearly 4 minutes. 4 minutes it has to wait. So this route is down also, it will not come to know immediately. It has to wait for 4 minutes to come to know that information. So this is one of the disadvantages. Then it does not support the unequal cost load balancing. If it is a different metric also, it should support it, but it is not support, then we cannot use the links efficiently. For example, I have the two paths, one is having 2 hops, another one is having 3 hops. Okay, I want to make use of both the links, then it will not work out. If the two links having the two hops, then it will support it. That was the one of the main disadvantages, which is does not support unequal cost load balancing. And then failure metric, hop count. See, for example, I have 3 paths. The path, this path having 3 Mbps, but I having 4 hops. Then below path is having a 5 hops, but it's a 10 Mbps. But middle path having 2 hops, but it is having only 64 kbps. It's a very minimal bandwidth, but because of this hop count, this path will be selected as a best path. Optimally, this path has to be selected as a best path, 10 Mbps path. If it is a more hop also, it should be selected. Then only the data can be transmit faster. But because of this routing protocol limitation, it looks only hop count. It is doesn't not look a bandwidth. So it will choose this path. Then the data will be sending the slower. This is one of the failure routing protocol because of this hop count. Why? Because it will look only hop count. It will not look a link capacity. If it is looks a link capacity, this path could be taken. But here it looks the path hop count. So it has chosen this. So the data will be transmitting very slowly. Thanks for watching NetTalks Tamil. Please like it, share it, subscribe it. If you have any doubt, please drop your doubt in comment box. It will be addressed in upcoming videos.